All right, so now we're going to talk about the binomial theorem. So a binomial is anything that's got two terms, and we're going to be raising it to increasing powers. Okay, so the first one we're going to do, and we're going to use a plus b. So a plus b, this is a binomial. We are going to raise this to the 0th power. Okay, so sort of uninterestingly, anything to the 0th power is 1. Okay, next we're going to have a plus b to the 1, which would just be a plus b. Okay, next is going to be a plus b squared. Okay, so if I want to do that, I'm going to do the math off here to the side. A plus b times a plus b, right? We're going to FOIL that. So we have a times a, which is a squared, a times b, b times a, and b squared. So we get a squared plus 2ab plus b squared. Okay, so I'll put that over here. A squared plus 2ab plus b squared. Okay, next is going to be a plus b cubed. Okay, so to do that, again, I'm going to go off to the side. That's going to be a plus b squared times another a plus b. Okay, so I'm going to take my last result, which was a squared plus 2ab plus b squared, multiply that by another a plus b. Okay, so what I'm going to do is I'm going to distribute through the a, and I'm going to distribute through the b, and then we'll collect all our like terms. Okay, so a times a squared is going to be a cubed. 2ab gives me 2a squared b. Multiply that by a gives me an ab squared. Okay, so I've done all the a's. Now I'm going to go through and do all the b's. So we're going to have a squared b. Multiply this one. 2ab squared. And then a b squared times a b is b cubed. Alright, so let's clean that up a little bit. So we've only got one a cubed. Okay, I have a 2a squared b and 1a squared b there. So that's 3a squared b. I have ab squared, so I have 3 of those. And then the 1b cubed. Okay, so let's add that to our list over here. So we have a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, next up, we're going to do one more of these the long way, but hopefully you're already starting to see some patterns. Okay, we're going to do a plus b to the 4th, which means I'm going to multiply the last thing I did by another a times b. So I'm going to do that over here. So I'm going to take a cubed plus 3a squared b plus 3ab squared plus b cubed, and I'm going to multiply that, and I'm going to do this underneath, times a plus b. Try it again. Okay, and I'm going to organize it a little bit more. So I'm going to multiply all of these by a. So we're going to have a to the 4th plus 3a cubed b plus 3a squared b squared plus an AB cubed. Then I'm going to go through and multiply them all by b, and I'm going to line them up by their like terms here. So b times an a cubed b is going to be a cubed b. This one times the b is going to be a 3a squared b squared. Multiply this one is going to give me a 3ab cubed, and then the last one will be b to the 4th. Okay, then I can add all these up. So a to the 4th, 3 and 1 gives me 4a cubed b. 3 and 3 gives me 6a squared b squared. 4ab cubed and a b to the 4th. Okay, so as we increase the power, the algebra here is getting a little bit more painful. But again, there's some patterns. So let me add this one to the list, and then we're going to look at some of the patterns. So we have a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a, let's give this some room here, 4ab cubed plus b to the 4th. Okay, so let's talk about some of the patterns. So the patterns here, okay, if we look at the coefficients, okay, it's brand new to you, but if I pulled out all the coefficients, so here I pull out the coefficients, I just have 1. Here I have 1 and 1. Here I have 1, 2, and 1. Here we have 1, 3, 3, 1. Here I have 1, 4, 6, 4, 1. Okay, which is Pascal's triangle. Okay, so the coefficients are coming from Pascal's triangle. The next pattern, okay, looking at the powers of a. So if we look at the powers of a, and I'll use this last one as an example, it's going to start with whatever the power is, and then it's going to decrease by 1. Okay, so we have 4, 3, 2, 1, and we'll call this a to the 0. Okay, versus the powers of b, which are going to start at 0 and go up by 1. 1, 2, 3, 4. Okay, so again, the 3 patterns, the coefficients come from Pascal's triangle, the powers of a start at whatever the power is and descend, and the powers of b start at 0 and ascend. Okay, so now let's say I want a plus b to the 8th power. Okay, so we could see how this is very painful and multiply a plus b times itself 8 times. But now we're going to use the patterns. Okay, so the first thing I'm going to do is pull the 8th row of Pascal's triangle. Okay, so here is Pascal's triangle. So I am going to use the 8th row. The 8th row is the one that starts with 1, 8. So we have 1, 8, 28, 56, 70, 56, 28, 8, and 1. So I'm going to write those out. Okay, so we're going to have a 1, I'm going to leave a space, 8, leave a space, 28, leave a space, 56, leave a space, 70, leave a space, 56, 8, nope, 28, 8, and 1. Alright, got it all there. Okay, now I'm going to take my a, raise it to the highest power, so a8, a7, a6, a5, a4, a3, a2, a to the 1st, and a to the 0. Then I'm going to take my b and increase it. So there's no b here. b squared, b cubed, b to the 4th, b to the 5th, b to the 6th, b to the 7th, and b to the 8th. Okay, so if I write this, that's it. So ignoring the 1s, we have a to the 8th, a to the 7th b, 28 a to the 6th squared, and so on. All right, so we're going to do 2 more examples where the binomial itself gets a little bit more complicated, just to see what happens. So the first thing is still just to pick the row of Pascal's triangle. So if this is to the 6th power, we're going to have the 6th row, which is going to be 1, 6, sorry, gotta look, 15, 20, 15, 6, and 1. Okay, then we take the first thing. So x to the 6th, we're going to have x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x, and then that would be x to the 0. Then we will have the 2y increasing, so 0, this is going to be 2y, this is going to be 2y squared, 2y cubed, and notice I'm putting them in parentheses, and 2y to the 6th. Okay, I'm putting it in parentheses because the y will get raised to the power, but the 2 will as well. Okay, so this is going to take a few more steps. Alright, so x to the 6th will just be x to the 6th. Then we're going to have 6 times x to the 5th times 2 times y. So the 2 and the 6 get multiplied. Okay, then I'm going to do the rest of these in a couple steps here. So we're going to have 15 x to the 4th. This is going to simplify to 4y squared. 2 cubed is 8y cubed. 15x squared 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6th is 64. Y to the 6th. So the last thing I'm going to do is multiply the 15 and the 4, the 20 and the 8, the 15 and the 6, and so on. So after I do all the multiplication, the coefficients are now 12, 60, 160, 240, 192, and 64. Okay, so we're going to do one last one. And this has 3 things that are going to change our end answer. So the coefficient, and we've already seen what happens with that. It's going to have a power within the power and a negative. Okay, so we're still going to start off with our Pascal's triangle. So we're going to have 1, 5, let's leave a little bit more room, 10, 10, 5, and 1. Okay, then we take the 2x and decrease the powers. So in parentheses, 2x to the 5th, 2x to the 4th, 2x cubed, 2x squared, 2x, and no 2x. Then we take the negative y squared in its entirety. So this is going to be, squeeze it in here, negative y to the first power, negative y, sorry, squared, 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 negative y squared cubed, negative y squared to the 4th, and negative y squared to the 5th. Okay, now I know it's really tough to see the same, but we'll get through it here. So, what's going to happen with the negative, even though it's a negative y squared, that doesn't mean this negative goes away. The y squared happens first, and then we're subtracting that. The powers that we're introducing over here, though, if we're raising it to an odd power, like 1, it's going to be a negative. If we raise it to an even power, like the squared, it's going to be positive. So I'm going to go through and do just some simplifying. Okay, so here we're going to have 2 to the 5th, so this is going to be 32x to the 5th. This term will be negative, so minus 5 times 2 to the 4th is 16. Okay, x to the 4th, y squared. My next term here, we're going to have a negative squared, so that one will be a positive again. We've got the 10, we've got 2 cubed. Okay, and then we have negative y squared squared, so that's going to be y to the 4th. Next one's going to be a negative to the odd power, so it's going to be negative 10. 2 squared is 4x squared. Then the negative y squared cubed is going to be y to the 6th. I already put the negative out front. This next one will be positive since it's to an even power. And then y to the 8th. The last one will be a negative y to the 10th. So the last step is to multiply. So I'm going to pause it and do that. Okay, so there's our final result. So the powers no longer, or the coefficients no longer look like Pascal's triangle because of the 2. The terms are going to alternate because of the negative. And then the powers of y look different. So instead of 0, 1, 2, 3, 4, and so on, it's 2, 4, 6, 8, and 10. In this last video, we're going to talk about if you want just a specific term in the binomial expansion. So we could write out the whole thing, but if I want something specific, we're going to use this formula. So if I have x plus y to the nth power, it's going to be n, choose r, so remember this is a combination, x to the n minus r, y to the r, where r is 1 less than the term you want. Okay, so my first example, I want to find the 5th term of 2x minus y to the 9th. Okay, so I'm going to bring up my Pascal's triangle. Okay, so if I wanted the 9th row, we're looking at this entire row here. Okay, so in that expansion, there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different terms. I want the 5th. Okay, so visualizing it on the Pascal's triangle here, this would be 1, 2, 3, 4. I'm looking for this term right here. Okay, so using this formula here, my n is whatever the power is. So that's going to be 9. R is 1 less than the term I want. So if I want the 5th term, R is going to be 4. This is going to be x, which in this case is 2x, n minus r. So 9 minus 4 is 5. Y to the r is still 1 less, so this would be to the 4th, negative y to the 4th. Okay, so to do this, you have options. You can use the combination formula in your calculator and do 9c4, or you can go to your Pascal's triangle and go 0, 1, 2, 3, 4 to get that 126, or you use the calculator and do 9 to get 126. So this is 126 times 2 to the 5th is 32. Negative y to the 4th is a positive y to the 4th. And if I multiply 32 and 126, we get 4032 x to the 5th, y to the 4th. So in my last example, we want to write the term in x minus 3y to the 5th, where the exponent of y is 2. Okay, so we're going to kind of work backwards. Okay, I'm going to have my combination. I'll fill that in. We're going to have x to something, and I'll leave a little space, and negative 3y to something. We do know that something, though. That's going to be 2. Okay, so working backwards, that means my r is 2. So this will be 2. My power is 5, so that's going to be 5, 2. Then for this, that's going to be n minus r, which is going to be 5 minus 2, which is going to be 3. Okay, the 5, 2, again, you can use Pascal's triangle, or you can type it into your calculator, but you're going to end up getting, 10. X cubed, negative 3 squared is going to be a positive 9, y squared, 10 times 9 is 90, x cubed, y squared would be the specific term where the exponent is 2.